So this is an example of a problem 6 in our section 8 web assignment, where we're having to solve for sigma. And it says the null hypothesis states that mu is equal to 15.6, and it was tested against the alternative hypothesis that mu is less than 12.6. So that makes this a left-tailed hypothesis test. A sample of 50 resulted in a calculated p-value of 0.019. If x bar is equal to 14.4, oh, sorry, that was Clarence. Sorry, buddy, you okay? Find the value of the population standard deviation correct to 2 decimal places. So first we have to recognize that we know how to find our z-test statistic using the formula that's given there from our formula sheet. We also have to recognize that we were told that mu is 15.6, so that's the underlying assumption. We were told that the sample size is 50, that the sample mean is 14.4, and we're wanting to find the value of the standard deviation. So the first thing we're going to need to do is find the z-score that corresponds to an area below it because of the left-tailed test, the less than alternative. The z-score that corresponds to the area below it equal to 0.019. This would involve using our norm.inverse command, where the area below is 0.019, and since we're finding a z-score, our mean is 0, and our standard deviation is 1. So when I did that in Excel, I got a z-score of negative 2.074854734. I'm going to try not to round that so that I get a more accurate result for my sigma when I use a little bit of algebra. So now that we know our z-score, we can substitute it into our z-test statistic formula. Now my tablet's not being cooperative with me today, so I'm going to have to type this. So plugging it into that formula up above, we now know that z is equal to negative 2.075-ish, but I'm going to use the full value. And we set that equal to our x bar, which was 14.4, minus the given mean, the assumed mean in the null hypothesis of 15.6, divided by the standard error of our sampling distribution, which we know is our sigma over the square root of n. And n we know is 50. So now the question is, can we use our algebra skills to solve for sigma? Well, let's first recognize that that numerator on the right-hand side becomes negative 1.6. It is being divided by a fraction, sigma over the square root of 50. We want to isolate sigma. So what we need to do is we need to recognize that since negative 1.6 is being divided by that entire quantity, which is a fraction, then that's the same as multiplying by the reciprocal. So we could look at it this way. We have the z-score that we calculated in Excel, and then it'd be negative 1.6 times the reciprocal of our standard error, which would be the square root of 50 over sigma. Okay, so again, keep in mind we're solving for sigma. So since we're dividing by sigma, when we solve for sigma, we're wanting it to be up on top, not down on bottom. So we'd have to multiply both sides of the equation by sigma. So we'd have sigma times negative 2.074854734 is equal to, now when we multiply the right-hand side by sigma, it cancels out. So we'll have negative 1.6 times the square root of 50. Notice I'm not grabbing my calculator yet to calculate anything. I don't want to do any rounding along the way. So finally, to get my sigma alone, I notice that it's being multiplied by the z-score. Therefore, to undo that multiplication, we need to divide both sides by that z-score. So we're going to take the negative 1.6 times the square root of 50, and we're going to divide by the z-score, negative 2.074854734. This will give us our sigma. And when I calculate that value, I find that sigma is equal to 5.45 if we round to 2 digits after the decimal point. So you could go back and plug it into the original equation. You could go back and you could say, all right, z, which we now know is negative 2.074854734, must equal the negative 1.6 that we got when we subtracted our x bar minus mu, divided by the standard error, which must be put in parentheses because you're dividing by the entire quantity, and we can substitute in our 5.45 value over square root of 50. If you calculate the left and right hand side of that equation, you're going to find that they do come out to be equal to each other. Now it's going to be a little bit off on the right hand side because we did round sigma to 2 digits after the decimal point. Let me know if you have any questions.